All right, let's see if I can talk about these notes fairly quickly. There's polar coordinates. We're going to learn what polar coordinates are. Usually we have rectangular coordinates. We're familiar with that, where this is how much you move on the x-axis, this is how much you move up and down on the y-axis, or in the y direction. And you plot those like normal. Polar coordinates are different. They have a radius and an angle, and we're going to see how to graph that. So the radius is going to be a distance. It can be positive or negative. Negative just means you go backwards. Positive means you go forwards. And the angle is just the angle from the x-axis. So let's see an example. It says plot 4, 270 degrees. To start plotting, you first pay attention to the angle, and you're going to move that angle. So like whatever that is, you're going to find that angle. 270 degrees corresponds to this. You can use your unit circle. And then from the origin, which is now called the pole if you're in polar coordinates, but I'll just call it origin. From the origin, you go out 4, because it says 4. Something that we said in class was if it's negative 4, then you go to that angle, and then instead of going forwards, you go backwards. This corresponds to negative 4, 270, because you go all the way to 270, but you go backwards, you don't go forwards. And that's the same thing as 4, 90, because you can go up 90 and then up 4 in the forwards direction and still get the same ordered, point. Coordinate. There are an infinite number of ways to write down a single point in the polar coordinate system, because you can just keep going around and around the circle. So if we went like 360 plus 90, what's 360 plus 90? I think it's 450. I know it's 450. And then go up 4, we would have the same point. And even if we went negative 270, we would be backwards this way, up to here, and then up to positive 4. That would be that angle, or I mean that version. There's a bunch of different ways to write down the same ordered pair. But to plot 4, 270, that's this. You go over 270 and then out a distance of 4. To find a rectangular coordinate for this, first I would plot this. So 2 pi over 3, I think that's 120 degrees. That would be this. So I go there, and it's negative 3, so remember I go backwards. I plotted positive 3 there, but negative 3 is backwards. Okay, so I first plot it. That's how I got this. And then I draw this triangle. Once I have this triangle, I'm going to try and find the rectangular coordinates by finding the x and the y. So I first have to figure out this angle. And then I'll just use my Sohcahtoa stuff, because it's the right triangle. So to find this angle, I know that from here to here is 270, or no, 2 pi over 3, sorry. This is 2 pi over 3, which is, I think, 120, because it's the same as that. And then this is 180. So to find this angle, I just take 180 minus, I'll take the 180 and I'll minus 120. And that's how I get this angle here. That's what I did. So it's 60. So this angle, I just redrew this triangle, is 60. And then I can find the x and y by using Sohcahtoa. Sine would be opposite over hypotenuse. So sine of 60 is y over 3. And I solve, and I get this. And then same with the x, except for I use cosine of 60 degrees equals x over 3. And then I multiply both sides by 3, and I get 3 over 2. And there we go, the x coordinate and the y coordinate. That was kind of fast. You should probably pause it and see if this makes sense, or rewatch it. Something that's kind of convenient is using these formulas to convert to rectangular coordinates. You can use x is equal to r cosine of theta, because we had x equal to the radius times the cosine of this reference angle. Remember, the whole entire angle was 270, and then you go backwards. So the angle that we use here is not 270, sorry, 120. It's not this angle. the angle that we use here is not the same as that angle. This angle, which is here, is from the triangle that you draw. So theta is the reference angle in the triangle that you make, not the overall angle. So that's important to know. Tangent is just y over x. It's just defined. I'll show you that in a little bit. Find the polar coordinates for 2, 2 root 3. I just found this as a decimal. First I'm going to plot this. These are rectangular coordinates. I'll plot it over 2, up 3.46, blah, 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 blah. It's almost 3.5. So I plot that, and then I draw a triangle. So I'm trying to find a theta, and I'm trying to find a radius. So I'll draw the triangle, and I'll find this angle, because I need that angle, right? Because that's the angle for the polar coordinates. And that is, I can use Sohcahtoa, so tangent would be 3.46 over 2. I rounded it to write it down, but I didn't round it when I actually put it in. So I actually put in 2 root 3 on top here. Divide by 2, use arc tangent, and I would get 60 degrees. So my theta that goes here is 60 degrees. And to find r, r is the hypotenuse, so I can just use Pythagorean theorem. And then a squared plus b squared equals c squared, and I get 4. And so the polar coordinates for that point are 4, 60. And that's it. That's all the notes. I'm going to stop it now.